Hello class. In lesson 4.3, right triangle trigonometry, you'll learn to find the value of trigonometric functions of any angle, and use special right triangles to find the missing side on right triangles. So let's begin first with trigonometry. Trigonometry is the study of relationships among the sides and angle measures of a triangle. A trigonometric function trigonometric ratio compares the length of two sides with respect to an acute angle theta in a right triangle. And a trig function or trigonometric function is a rule defined by the trigonometric ratios. Now there's a total of 6 trig functions. They are labeled sine, cosine, tangent, cosecant, secant, and cotangent. Now, the trigonometric ratio to each one of these 6 trig functions is defined by an angle theta in the triangle and the hypotenuse, the opposite side of that theta, and the adjacent side of this theta. So if this theta was over here, the hypotenuse would be in the same location, but this side would be considered the opposite side of theta, and this would be considered the adjacent side of theta. So it's all relative to, again, the acute angle that we're looking at. So if our angle is down here, was using this theta there as our angle, the sine of this angle theta equals to the ratio of the opposite side of theta divided by the hypotenuse of the right triangle. The cosine of this angle theta equals to the ratio of the adjacent side to theta divided by the hypotenuse of the right triangle. And tangent of this angle theta equals to the ratio of the opposite side of theta divided by the adjacent side to theta. Now, the next one is called the cosecant. The abbreviation for cosecant is the letter CSC. So the cosecant of theta equals to the hypotenuse divided by the opposite. The secant, which is abbreviated as SEC of theta, that equals the hypotenuse divided by the adjacent side. And cotangent, which is abbreviated COT of theta, that's the adjacent side of the angle divided by the opposite side of theta. So these are the definitions, and for each one of cosecant is 13 divided by 12. Here, let me start over. Sine again is defined as the opposite divided by the hypotenuse. So since the opposite side measures 12 and the hypotenuse cosecant of theta is the hypotenuse divided by the adjacent. I'm sorry, by the opposite. So that's 12 over 13. 12 over 13. The secant, that equals to dividing the hypotenuse by the adjacent side, which those numbers are 13 over 5, and cotangent divides the adjacent side by the opposite side, which are 5 over 12. So there, those are your 6 trig functions for the angle theta. That's what they equal to. They equal to, again, these ratios. Now you'll notice again, and you probably already picked this up, that sine and cosecant are inverses, are reciprocals of each other, not inverses, reciprocal of each other's. We end up with, oh, I wrote this number wrong. This should be 13 over 12. 13 over 12. I wrote that incorrectly. So let me fix that. There we go. You'll notice now again that 12 over 13 and 13 over 12 are reciprocals, just like 5 over 13 and 13 over 5, 12 over 5 and 5 over 12, which means that these functions are reciprocals of each other. Sine is a reciprocal of cosecant, cosine is a reciprocal of secant, and cotangent is a reciprocal of cotangent, and vice versa. Cotangent is reciprocal of tangent, and so on. So we can figure out the remaining 3 functions, trig functions, by simply flipping the original 3. Now, to do this example right here, well, we need the 3 sides. So here we're going to use Pythagoras' theorem, a squared plus b squared equals c squared, to figuring out the side opposite of the hypotenuse, which in Pythagoras' theorem is c. So here we're going to start by getting 6 radical 3 squared plus 6 squared equals c squared. 6 radical 3 squared, that's going to give us a total of 108. 6 squared is 36. And that adds up together for a total of 144. Taking the square root, we get that the value of c is 12. So this length here measures 12 units. So now we can figure out the 6 trig functions. So let's label again the 3 sides. Well, again, our angle theta is right here. So we're going to find the 6 trig functions to this angle. So again, this is obviously the hypotenuse of the right triangle. But since theta is here, the opposite side is literally across from it. So this is the opposite side, and this has to be the adjacent side to theta. Again, the opposite and the adjacent side are always the sides that intersect at a 90-degree angle. But to determine which one's the opposite and which one's the adjacent, again, you have to look at what is literally opposite of our angle. If theta was over here, then our 2 sides would switch. This side, 6, would be the opposite side, and then this side would be the adjacent side. So again, it all depends on where the angle is. So let's find sine. Well, sine, again, divides the opposite side, which is 6 radical 3, by the hypotenuse, which is 12. Well, you'll notice again that 6 and 12 have a common factor, so we can reduce by 6. 6 divided by 6 is 1, and 12 divided by 6 is 2. So we end up with 1 radical 3 instead of 6 radical 3 divided by 2. Now, cosine divides the adjacent side, 6, by the hypotenuse. And well, that simply reduces to 1/2. Tangent divides the opposite side, which is 6 radical 3, by the adjacent side, which is 6. And well, here, 6 and 6 are common factors, so that's going to just simply be 1 over 1. So 1 radical 3, which is just radical 3 divided by 1. So there you have it. And because cosecant is simply the inverse to this, we're just going to flip it. So this is 2 radical 3, which again we cannot leave like this. Now we cannot leave our answer like this. We have to rationalize this. We're not allowed to have a irrational number in our denominator. And the easy way to rationalize this is by multiplying by the denominator. And look what happens. When I multiply by the denominator, what simply happens is this, is that this basically moves to the top, and our denominator simply becomes the number inside the radical. So this rationalizes 2 radical 3 over 3. That 3 comes from right there. Mathematically, what we're doing is multiplying the top and the bottom by the square root of 3, by that irrational number. Multiplying 2 irrational numbers together, or multiplying the same irrational number, makes it rational. Okay, because I can't say any 2, because radical 2 times radical 3 is not going to become rational. I have to multiply the same irrational number together to get a rational number out of that. So I would multiply a radical 3 on radical 3, which again is going to become simply that. Now for secant, well, secant is the inverse of cosine, which is 1 over 2. The reciprocal of 1 over 2 is just simply 2. And cotangent is the reciprocal of tangent, and tangent is radical 3. So the reciprocal radical 3 is 1 over radical 3. So again, we need to rationalize this. So rationalize this would be 1 radical 3 divided by 3. And there, those are your 6 trig functions. Okay. Now, and like we mentioned before, because the cosecant, secant, and cotangent ratios are reciprocals to sine, cosine, and tangent, they are called reciprocal functions. And the identity, and they're defined as followed. Cosecant of theta is simply 1 over sine of theta. The secant of theta is 1 over cosine of theta, and the tangent of the cotangent of theta that's 1 over tangent. So if I want to find missing trig functions, I know one already, that the cosecant of theta is 37 over 12. Well, because of the inverse property, the inverse of cosecant is 1 over sine. So therefore, that means that the sine of theta is simply this number, the reciprocal of this number. So that's going to be 12 over 37. Now to figure out the remaining 5 trig functions, I'm going to use the fact that I know that sine is the opposite over the hypotenuse on a right triangle. So if I draw myself a right triangle and I put my theta here, this is the hypotenuse. This would be the opposite side of this angle theta, and this would be the adjacent side to this angle theta. Well, according to this ratio here, I know that the sine of this angle is the ratio of 12 over 37, which means that the opposite side is 12 and the hypotenuse is 37. And well, I can then again go back to the Pythagorean theorem and figure out the missing side, which in this case is the adjacent side. So if I use a squared plus 12 squared, make this a for adjacent, the opposite side b, and obviously the hypotenuse is always c, I get a squared plus 12 squared equals 37 squared, which is 144, and 37 squared, hold on, that is 1369. And here I would subtract the 144. So a squared equals to 1369 minus 144, which is 1225. Taking the square roots of that answer, we end up with a total of 35. So the value of A is 35 units. So this is 35. Okay, now we can figure out the remaining 5 trig functions. Cosine would be the adjacent side of 35 over the hypotenuse. Tangent is the opposite side over the adjacent. And secant is simply the reciprocal of cosine, so that's 37 over 35. And cotangent is the reciprocal of tangent, so 35 over 12. And here are the remaining 5 trig functions, simply using the fact that the cosecant is 37 over 12. Let's see, let's do another example like that. Okay, here we're given that the secant of theta is 4. And well, secant is 1 over cosine of theta. So that means that the cosine of theta is simply going to be the reciprocal of this number. Well, this is a whole number 4, which is 4 over 1. And the reciprocal of 4 would be 1 over 4. And since cosine is the adjacent divided by the hypotenuse, that means if I draw myself a right triangle over here, and make my angle theta here, this side would be the opposite side of theta, this side would be the adjacent side of theta, and of course this is your hypotenuse. So we are given again that the adjacent side is 1, so this side over here measures 1. The hypotenuse measures 4, so this side over here measures 4. And all I'm missing is to figure out, again, the opposite side. So from a squared plus b squared equals c squared, I'm simply going to substitute in for a, we'll make a for adjacent 1, so 1 squared. We don't know what the b value is, and that's going to equal to the hypotenuse, which is 4. Well, raising both of these numbers to the second power, we end up with 1 and 16. We'll subtract 1 from both sides, so 16 minus 1, that's 15. And then taking the square roots, we get our answer for b. So b equals the square root of 15, which does not simplify to anything. So we end up with the square root of 15. There's no perfect square factor inside there, so there's no way to simplify that. So now we can figure out the remaining trig functions. We need sine. We do not know the sine of theta. So the sine of theta is the opposite divided by the hypotenuse. Tangent of theta is the opposite divided by the adjacent. So that's just the square root of 15 since we're dividing by 1. Cosecant is the reciprocal of sine, so that's 4 over radical 15, which we need to rationalize. So the rationalized form is 4 radical 15 over 15. And then the last one is cotangent. We don't need to figure out secant because, again, that one's given to us from the beginning. That's 4 over 1. And cosecant is the reciprocal of tangent, so 1 over radical 15, which rationalizes to 1 radical 15 over 15. So there you have the remaining 6 trig functions. Okay. Now, another way of figuring out, again, the sides of these triangles for specific and unique right triangles are the 30-60-90 right triangle and the 45-45-90 right triangle. Those are frequently used, those angle measurements are frequently used in trigonometry. And you can use your knowledge of the sides of the relationship in these special right triangles to find the values of the trigonometric ratios. So for example, on a 30, 60, 90 triangle, if you remember from geometry, the shortest angle, the smallest angle, opposite of the smallest angle is going to be the shortest side. So this side right here is the shortest. Okay, that's going to be the shortest. The shortest leg. Opposite of the 60-degree angle is going to have your other leg, the bigger leg. And then, of course, the hypotenuse is going to be the longest leg. The hypotenuse always has to be the longest of the three sides on a right triangle. Now, the relationship between these three sides is that whatever the shortest leg value is, let's say it's n, the longer leg, the leg opposite of the 60, is going to be whatever that number is times the square root of 3. And the hypotenuse, the relationship between the short leg and the hypotenuse, the longest of the three legs, is going to be 2 times whatever that number is. So let's say that the triangle has the shortest leg is the 30, 60, 90. And let's say that the shortest leg is 4. If this leg is 4, that means that this side will be 4 times the square root of 3. And this would be 2 times 4, which is 8. This length right here would be 8. And using that idea, we can then figure out, or if we know that this is, let's say, 16, if this side is 16, well, because it has to be twice this measurement there, that means that this has to be 8. Again, 8 times 2 is 16. And if we know that this is 8, now we can figure out the longer leg by simply multiplying 8 with the square root of 3. So let's look at some examples of that. Let's look at this example right here. Now we have a 60, 90, so that automatically by default makes this a 30-degree angle right there. Now remember, the inside of a triangle has to add up to 180. So since, again, this is 90, the square right here is 90, plus this 60-degree there, plus this unknown, which I kind of told you already is 30, has to add up to 180. So if I say I don't know what that one is, I can figure out by subtracting 180 by 90 and 60, and that obviously is going to equal to 30. But if we know one angle is 90 and the other one is 60, well, this one has to be 30 again because of that math. Now let's call this X and let's call this Y instead of the letters M and N. Okay, so since the relationship between the three sides on a 30, 60, 90 triangle is the following, we can set up equations to figure out what the value of X and Y is. Well, on the opposite of the 30-degree angle is the shortest side, so we're going to label that as N. So N equals to 10. Opposite of the 60-degree angle is going to be the value of N times radical 3. So X equals N times radical 3. And opposite of the hypotenuse, opposite of 90 degree, your hypotenuse, that side is always going to measure 2 times N. So that means Y is equal to 2 times N. And since we know again that N equals to 10, we can figure out the value of X by multiplying 10 with the square root of 3 and multiplying 2 times 10. So my answer is going to be 10 radical 3. We're going to keep this as a rational number, as a exact answer. So we're not going to get the decimal value. We're going to write it as 10 radical 3. And then 2 times 10, well, that's 20. So the value of X is 10 radical 3, and the value of Y equals 20. So those are the sides, the hypotenuse and the longer leg on this right triangle. Let's see, let's do another example. So again, because we have a 90-degree angle here, 60 degrees down there, that means by default that this is going to be 30 degrees. Now, what's the relationship of the three sides? Well, remember, on the opposite of your smallest angle, 30, on the opposite side, that's going to be the smallest side. So that's going to measure N. So here, V is equal to n. On the opposite side of your 60-degree angle, so here's your 60, that side there, this side right here, that has a measurement of n times radical 3. So 5 radical 6 is equals to n times radical 3. And across the hypotenuse, that side has a side measurement of 2 times n. So u is going to equal to 2 times the value of n. But here's the problem. We do not know what the value of n is. But we can use this middle equation here to figure that out, because we know that n times square root of 3 has to give me the answer of 5 radical 6. So let's set up that equation. And let's do n radical 3. And we're going to set it equal to 5 radical 6. So to solve this equation, we divide by radical 3. This reduces, and we get that n equals to 5 radical 2. So that's the value of n. So here v, since v equals to n, v is equal to 5 times the square root of 2, and u is equal to 2 times that value. Sorry, that should be a 2. Again, the value of u is 2 times the value of n, and we know that n, again, is that number right there. So substituting in that number here and that number there, we're going to get 10 radical 2 for the second one. So there are our answers. V is equal to 5 radical 2, and u is 10 radical 2. There you have it. Okay, now for a 45, 45, 90 triangle, well, this creates an isosceles right triangle, which means that these two sides, these two legs here, are going to be of equal length. Those things are congruent. So this side and this side are going to equal to the exact same numerical value, since one is not shorter than the other. The relationship is that they're both the same length. Now, the relationship between either of these two legs and the hypotenuse is that the hypotenuse equals to this n, the length of the legs, times the square root of 2. So this is a special relationship on this type of triangle. So let's look at how we use this again to solve an equation. So here we have again a 45, 45, 90 right triangle. And again, the relationship between the three sides, the two legs, and the hypotenuse is that the legs again are congruent. So they're both going to measure the exact same thing. So x is equal to n and y is equal to n. Now the hypotenuse, again, this length right here, well, that has to equal to the value of n times the square root of 2. So that means that this side here measures this. So if I set up an equation and I get n radical 2 and equal it to the length of 10 radical 2, I can now figure out the value of n. And this I do by simply dividing by that square root of 2. Since I'm multiplying, this reduces to 1 and n equals 10. So the value of n is 10, which means that x equals 10 and y equals 10. And there's your answer. So this one's pretty simple, because if we know what the hypotenuse is, all we have to do is just simply divide by the square root of 2. Like in this example right here, I know that the hypotenuse again is going to be 9, and the relationship between the two congruent legs, which both measure the same thing, is that the hypotenuse has to measure n times radical 2. And in this situation, we want this n radical 2 to give me an answer of 9. So dividing 9 by the square root of 2 equals 9 over radical 2, which we have to rationalize, and it gives us this. So n equals to 9 radical 2 over 2. And since both x and y equal to the value of n, that means that x equals to this answer and y equals to this exact same answer as well. And there you have it. There is their values for x and y on this right triangle. Using again these special ratios for your 45, 45, 90 right triangle and your 30, 60, 90 right triangle. Okay, well that concludes again the examples on lessons on right triangle trigonometry. If you have any questions, please send me a message or reminder through email. And again, I appreciate you watching and I hope you have a great day.